So today we'll see writing MapReduce application. Writing MapReduce application. Okay. So we can develop MapReduce application from anywhere. We need Eclipse IDE. First one, we need Eclipse IDE. So we can download Eclipse IDE from internet. It is completely free. So go to Google and search Eclipse download. So you will see first link. In this latest version of Eclipse is Simrel. So this is latest version. Okay. Click on this download packages. Click on this download packages. Here you will see Eclipse IDE for available for multiple languages. In this download Eclipse IDE for Java EE developers. Here you will see 64-bit. Click on this 64-bit. You will get a file. You'll get file. So let me show you. So you will get zip file. Once you extract that zip file, you will see Eclipse in this format. You will get zip in this format, zip file. Once you extract, you will get Eclipse folder. In this you will see Eclipse icon. Double click on this Eclipse icon or send it to desktop. You will see icon in this way. Click on this Eclipse icon. Click on run. It will ask workspace. So create workspace in your required location. So ours is Hadoop batch file. In this we are creating new folder. Folder name is MapReduce workspace. I am creating MapReduce workspace. So select MapReduce workspace. Click on OK. Click on launch. Step 2. Create a Maven project. Create a Maven project. Create a Maven project. So close this always show welcome icon. Close this welcome tab. Here right click on project explorer. Here you will see new. Click on others. Type Maven. Here you will see Maven project. Okay. So once again I am explaining. Right click on project explorer. Go to new. Click on other. Type Maven. You will see Maven project. Next. Click on next. Here you will see archetypes. Maven provides archetypes. Archetypes for different Java project structures. Java project structures. Maven provides different archetypes for different Java projects. Provides different archetypes for different Java projects. Example: standalone, web application, enterprise application. So there are different kinds of applications we develop by using Java. So for every Java project, it is providing different structure. So this is Maven-archetype-quick start, Maven-archetype-quick start. Quick start is for standalone application structure. Standalone application structure. We'll see later, right? So Maven-archetype-quick start is for standalone application structure. Standalone application structure. Application name. Under application name we see first src. Under src we write star.java. So application specific classes, application specific classes we write in this one src. Next one, test. Under test we write star.java. So these are unit test case classes. Next one, lib. Under lib we store star.jar file. So third party dependent third party jar files. Next, resources. Here we place star.txt, comma, star.csv, comma, star.doc, etc. If any files required in application, any files required in application, we place that files in this resources folder. This is standalone application structure. Okay, so select Maven-archetype, click on next. Here it will show group ID and artifact ID. Group ID, we give domain name, example com.qt. Artifact ID, we give project name. So package equal to group ID plus artifact ID. So project name we are giving MapReduce app. So let's create package name com.qt, and artifact ID I am giving MapReduce app. So finally, package name become artifact ID, group ID plus artifact ID. So com.qt.MapReduce app. So it will create standalone structure. So it is processing Maven archetype quick start. Once successfully completed, you will see standard standalone architecture. So first one, application directory. Under this one we see SRC. Under SRC, this is package name. Under package name, it will create default one app.java. Next, it will create SRC test. Under test, it is created app.test.java. So this is application class. This is JUnit class. These are default classes. If you don't want, remove these classes. Then right, next step is step 3. Step 3, write MapReduce application. MapReduce application. So we write the 3 classes, right? One is word count mapper class, and second one word count sorry, word count reducer class. Next one, word count driver class. Word count driver class. So we write 3 programs. In MapReduce application, we write 3 programs. So let me right click on this one, new class. I'm writing word count mapper. So I'm taking main method in it, finish. So we don't require main method. So this class must extends mapper class. Extends mapper class. So here it is showing some error. So if you observe, this mapper class is not available. So this mapper class is available in Hadoop API, Hadoop jar files. So we have to add dependencies in pom.xml file. Click on this pom. So next one, step 4 is, as a developer, we don't require anything, whether it may be distributed or local. To run our Hadoop application, MapReduce application, as a developer, whether it may be local or whether it may be distributed, least bother about as a developer. We write MapReduce application, we run that MapReduce application in Hadoop, whether it may be single node cluster or multi-node cluster. Okay. So step 4, add Hadoop and MapReduce dependencies. So let's add dependencies. So go to Google, and search Hadoop MapReduce, MapReduce, Maven dependencies, Maven dependency. So first we need one is uh, MapReduce client or MapReduce, Hadoop-MapReduce. Let me open first any one link, Maven repository link. So go to org.apache.hadoop, click on this one. Here you will see different dependencies. One is Apache Hadoop Common. Next one, Apache Hadoop HDFS, Hadoop Core, and it is showing MapReduce Core. So there are multiple dependencies. First, we need two dependencies. First one, Hadoop-Core. This one. Right click this one, open new link. Here you will see versions, different versions. So these all are different older versions, right? So for us, we want 2.x versions. So let me see Apache-Hadoop-Common. Yep. So here we are seeing 2.x versions. So here Hadoop core is available only for 1.x version. Hadoop Common, and next we have Hadoop HDFS. Next we have Hadoop MapReduce core. So let's first add, assume we are taking 2.7.6 or 2.9.1, any 2.x version. Click on this one, 2.9.1. Here you will see Maven, SBT, Gradle. We are using Maven, right? Click on this Maven, copy this dependency. Right click on here, copy, go to Eclipse, go to pom.xml file. Here you will see parent tag is dependencies. Under parent tag, you will see dependency tags. So after dependency tag, add our dependency. Okay. So we added Hadoop core. Next, go to browser. So go to Maven repository. Here copy MapReduce core. Right click here, new tab. So 2.9.1, right? 2.9.1. Click on this one. Copy this. Click on Maven. Copy this dependency. Add this dependency into pom.xml. Control A, Control Shift F. It will Eclipse format XML file. Click on Save. It is started downloading the dependencies. Building workspace. Once this is successfully downloaded, we cannot see any error. Once it is completed, I will explain this program. And let's observe, errors are gone. So completed downloading the dependencies, all errors are gone. Okay. Let's increase font size. So these are different data types available in Hadoop. Let's discuss Hadoop data types. Data types. For every Java data type. For every Java data type in Hadoop, we have equivalent data type. Equivalent data type. For every Hadoop data Java data type in Hadoop, we have equivalent data types. Yep. So Java and Hadoop. Java we have byte data type. So Hadoop we have byte writable. Short writable. Int writable. Int writable. For long we have long writable. For float we have float writable. For double we have double writable. Next, char character writable. For boolean writable. For string is not data type. For string, they have equivalent text writable. So for text, we have text writable. String, we have text writable data type. Any doubt? So why Hadoop require another data types? Why Hadoop require another data types? We have already Java has different data types, right? We are writing application in Java language. But why Hadoop require another data types? If you observe, yep. So this is our Hadoop cluster. In Hadoop cluster, we have data in multiple machines. Data in multiple machines. So assume your data presented in this machine, in this machine, in this machine. Assume your data is presented in 3 machines. So mapper process your data, right? Assume mapper processing here. Mapper processing here. So 3 mappers are initiated. 3 mappers parallelly processing your data. So mappers generate results and store intermediate results in local disk, right? So it is stored data in local disk. Assume reducer is initiated in this mission. Reducer is initiated in this mission. So we want to transfer this data. We want to transfer this data from these missions to reducer location mission, right? Yes or no? We want it to, this data is going to travel from mapper missions to reducer mission. All these intermediate results data is going to store in reducer mission. Then reducer process your data. So your data is presented in different variables. Data is presented in different variables. So internally this data is going to travel from one mission to other missions, right? So if any data but directly data is not going to travel from one machine to another machine through the network. JVM not allows you to transfer data from one machine to other machine through the network. So to transfer data from one machine to other machine, we use one serialization concept. Serialization in Java. If you apply serialization in Java, serialization to data in Java, then we can travel, we can transfer, or JVM allows you to transfer data through the network, data through the network. So by default, Java data types are not serialized. By default, Java data types are not serialized. So they developed separate data types. Every data type in Hadoop is serialized. Every data type in Hadoop is serialized. So we can transfer mapper intermediate output or reducer output through the network, So JVM allows to transfer your data through the network. So serialized means here Java has one special concept called serialized interface. So if any class implements a serialized interface, then JVM understand that you can transfer that class data through the network. Concept. Network. Through the network. So whenever your class, so all these Hadoop data types are classes. If you observe, capital letter. So all Hadoop data types are classes which are already implemented serialization interface. That's why we are able to transfer this data through the network. I too don't know, Jaydev, right now. So there is no concept of SERD, DSERD in MapReduce concept. So we have serialized concept. So every predefined Hadoop data type class implemented serialized. Okay. So that's why we are able to see, we are able to transfer this data through the network. Okay. So we have different data types. Coming to first word count mapper class. Word count mapper class. Word count mapper class. Suffixing mapper is optional. Suffixing mapper is optional. Here we are writing mapper. Suffix means after class name, if you add any name, suffix. Before write anything, we call prefix. So we are adding mapper to our class name, right? This is optional. Why we are writing mapper means clearly we can understand that this is a mapper class. Just for our understandable, okay, we are suffixing mapper to understand. Suffixing mapper is optional. Second important point, every user defined every user defined defined mapper class every user defined mapper class must be child class of child class of child class of org.apache.hadoop.mapreduce.mapper class. org.apache.hadoop.mapreduce.mapper class. So this is predefined class. So that if your class is child class mapper class, then only your class is initiated in multiple locations. Wherever data is available, it will initiate your class in data location. So here we see data is presented in 3 locations, right? So your class instance is created in 3 locations. We are not creating object, right? We are not executing our mapper class. We are submitting our mapper class to Hadoop. Hadoop will take care to create instance of your class object in data location. So your class is not we are not responsible to create object. Hadoop is responsible to create object internally in your data location. How it is creating multiple objects means, whenever your class extends this predefined class, then Hadoop understand that your class is a mapper class. Okay, if you not extend this class, then simply it understand that it is normal class. It is normal class, not mapper class. So whenever your class extend this one only, it will apply additional features. Okay, next point, we have to override we have to override we have to override map function. We have to override map function. So we have to override map function. So we override map function. So map function is from mapper class. So this is parent class. Parent class function we are overriding in our child class, so that our Hadoop calls map function on this data. Map function on this data. So Hadoop calls a map function on this data. Inside this map function, we write actual processing logic. Inside map function, inside map function, inside map function, we write. Yesterday we discussed in mapper we write separating key value pipes. First splitting each line based on delimiter. Next one, separating each line separating or splitting each line based on delimiter. Next one, preparing key value pairs. Preparing key value pairs based on requirement, we prepare key value pairs. Then we write key value pairs. We write key value pairs. So finally we write key value pairs. So we write key value pairs means intermediate key value pairs are writes in mapper location, local memory. So this we implemented here. So for map function takes 3 arguments. Map function takes 3 arguments. First one long writable, next one text, next one context. So map function takes 3 arguments. So before that mapper, here we are setting 4 arguments. So we are clearly saying this mapper requires 4 arguments. Two are input, 2 are output from mapper. For mapper class, word count mapper class, we get key value pair and it will write output as key value pair. We are defining at the class level, mapper class takes key value pair and gives output as key value pair. So this mapper class, this is generic syntax. Don't worry about this generic syntax. Clearly we are giving mapper takes key value pair and writes key value pair. So first input to key value pairs data types are long writable, text writable. So for mapper, for word count mapper, for mapper class, mapper class file hdfs file become input, right? hdfs file become input, hdfs file become input. So this is the file, this file is become input. So multiple blocks are input to multiple mapper instances. So this file is become input to mapper. So here mapper, we pass hdfs file as input to mapper, then mapper reads this file as a key value pair, as a key value pair. Then what is key, then what is key and what is value, what is value, what is key and what is value. So here assume we have a lines like we are passing file 1, name is file 1, this contain Hadoop is a big data framework. Okay, MapReduce is a big data processing engine, big data processing engine. So this is file. Assume this file is we are passing input to file 1 as an input to mapper class. So this file passed as an input to map function. Map function has key and value, and another one is conf. We have 3 parameters. Conf or context. So we have 3 parameters. So from this file, what is key? From this file, what is value? Let's leave about what is this context. We'll discuss it after discussion in map function. So from this file, what is key and what is value? So key is line offset, key is line offset, and value is value is entire line, value is entire line, entire line. First line, first line, key equal to 0, value equal to this entire line, key equal to 0, value equal to entire line. Second line, key equal to offset, right? Key equal to offset, right? So offset is calculated, offset is calculated all characters plus 1. For second line, how it calculates offset is all characters plus 1 including spaces. So first line characters are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, assume 2 spaces 12, 13, 2 spaces 15, 16, 17, 18, 19, 20, 21, 22, 2 spaces 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. 33 plus 1, 34 is offset number. 34 is offset number and value equal to entire line. So in this way, Hadoop passes for map function. For map function, it will pass first line. It will read from file. It will read first line and calls map function. Map function called automatically. We are not calling map function. Hadoop calls map function by reading first line. First line as passed as a value, key equal to line offset. For first line, there is no characters, right? Before first line, there is no characters. That's why line offset becomes 0. Next line, line offset equal to entire first line characters plus 1. Okay. So in this way, it will calculate line offset. Next, one important note I am explaining here. Map function automatically calls by Hadoop. We are not calling map function. Map function calls, map function executes for each line. If your file contain 10 lines, 10 lines, map function called 10 times. Map function called 10 times. So for each line, internally it will call, Hadoop calls map function. It reads each line and passes each line as an input to map function. Okay. internally Hadoop contain mechanism to split your data into each line. It will read each line and passes that line as an input to map function. So we got key is sorry key is line offset and value is entire line. Entire line is string, right? That's why we had taken string equivalent to Hadoop data type is text. That's why we taken text. I said we have Hadoop has multiple data types, right? We have byte equivalent to byte writable, short equivalent to short writable, int equivalent to int writable, long equivalent to long writable. Write one important note. Why we taken long writable as a key type? We have byte also, we have short also, we have int also. Why we taken long writable? Because we are dealing with big data, right? So file may be any size. So if you take integer data type size is 8 bytes. 8 bytes. Sorry, 4 bytes. 4 bytes. So long write is 8 bytes. So line offset is bigger size. Line offset may be bigger size. So to read entire file, we are taking key type is long writable type. Next, text writable, and inside text writable, so text writable we are converting into string form. Text writable again we converting string form. Why we are converting text writable to string writable form means string class contain some logics to split your string data into multiple lines. So here we are converting toString is a method. It convert any class object into string form. So text writable form to we are converting into string form by using toString. So line is converted to string. Then we are dividing line into multiple words based on space. So this data contain multiple words and each word is separated with space, right? Yes or no? White space. So there is a character SS. This is called regular expression character. So let's go regex Java Oracle. So these regular expressions are common in for almost all languages. Rules also almost common. So Oracle provides excellent link for regular expressions. This is the first link. So there are predefined classes, character classes. We have multiple concepts here. So there is one concept called character classes, not character. Predefined character classes. So slash d means digit. Digit. Slash capital D means except digit. Except digit. So here if you pass slash D means if digit is fine, it will split. If you use slash D, it will divide data based on digits. If you use slash means white space character. If it white space character finds empty spaces finds, it will divide data. Okay, why we are using slash means double slashes. So in Java, if you use single slash, after slash it will expect slash n slash t uh, predefined formatting characters. So we want to give an indication to Java. This is not for formatting character. This is expression. So if you give double slash means it will understand that this is not for formatting character. This is special instruction. So after that we are using slashes. So this split method divides your data based on white space. So white space means first line white space contain. First we get a word, is, a, big data and framework. So this split method divides your first data into multiple words and written as string array. String array form. It will written in string array form. Once we got array, right? From array, what we are doing? Word comma 1. Word comma 1. We are writing in mapper word comma 1, right? So from array, this is for each loop. So this contain all first line words, right? So each word we are taking for each loop, what it will do? It will read from first word. So words, right? These words contain Hadoop, comma, is, comma, a, comma, big data, comma, framework, right? What this for each loop do? For each loop reads each word. First it will read first word and assigns into word. Assigns into word. Then, so word is in string form, right? We want to write output in serialized form. So we are converting into string form to text writable form. So word and next one, word comma 1. So we are writing in this way, Hadoop comma 1. First word we are writing Hadoop comma 1, where we are writing this data, we are writing in intermediate results, right? So this intermediate results we point by using special class called context. So for mapper class, Hadoop internally pass intermediate local location context. Then whatever you are writing in this context object, it will write in local file system. Okay. So con dot write, we are writing word name is Hadoop 1. Next iteration, it will read is and it will write is comma 1. Next iteration, it will read a comma 1. Next iteration, it will read big data comma 1. So first line complete processing is completed. Next it will execute map function for second line. So this map function is called automatically based on number of lines presented in your file. Yep. First line processed. Next it will pass second line. What is second line? MapReduce is a big data framework. Then second line is splitted into multiple words. Each word it will adding word comma 1. So map function is executing multiple times based on number of lines presented in your data. Assume this block contain 5 lines, this block contain 5 lines, this block contain 5 lines. Your data complete file contain 15 lines. This 15 lines contain 300 MB. Okay. So this is 128 MB, 128 MB, 128 MB. So this data contain 5 lines, 5 lines, 5 lines. So here map function executed 5 times, here map function executed 5 times, here map function executed 5 times. All these are written intermediate results. All these intermediate results pass to reducer. Yep, that's it for today. We'll meet tomorrow.